This research is on a case study on synchronization. I am Anis Sekira Binti Razman from CS 2476C2. The abstract is this work attempts to provide an insight into knowing synchronization in parallel processing. There are myriad applications that use synchronization to improvise their methods. Synchronization has several types and challenges. Introduction. Synchronization is the coordination of parallel tasks in real time, very often associated with communications. It also means waiting by at least one task, and can therefore cause a parallel application's wall clock execution time to increase. Synchronization is used to prevent thread interference and prevent consistency problem. Definition. Operation or activity of two or more things at the same time or rate. There are three types of synchronization. First, barrier. Second, lock/semaphore. Third, synchronous communication operations. Challenges in data synchronization. Data formats. Complexity. Real-timeliness. Data security. Data quality performance. Background. This is the background of how synchronization were found. These are 5 paper reviews that I used for my research. Take a look. First paper review is synchronization in a thread pool model and its application in parallel computing. Advantage of thread pool model: our system can have a bound on the number of threads and reduce cost of thread creation. It is applied in barrier synchronization. It is a synchronized method and uses Java synchronization primitives wait and notify all. Here shows the differences from the synchronization for the thread per request implementation are. Here are the examples of synchronization before and after synchronization is applied. Synchronization is also applied in Jacobi iteration on finite differential equation to partial differential equations for a heat transfer problem. This is to ensure that every process has completed one update phase before any process begins the next one. They use barrier synchronization after each update phase. Here is the example of synchronization in Jacobi. Second paper review is time synchronization for high latency networks. A relatively dense deployment of sensor nodes, small yellow circles, are connected by wireless underwater acoustic links. These communicate, possibly via multiple hops, with each other and with tethered nodes, small green squares, at buoys to users on a platform or ship. Where possible, they can exploit a hybrid network with high-speed RF communication on buoys, large green squares, or with underwater or surface-based robotic or manually operated data mules, not shown. Apply time synchronization over multiple hops. Time synchronization over multiple hops can be done either to a single, common time base, as is typical, or with multiple independent time bases. Third, a media synchronization survey, reference model, specification, and case studies. Synchronization between media objects comprises relations between time-dependent media objects and time-independent media objects. Examples: lip synchronization, live synchronization, and a slideshow with audio commentary commands. The emphasis of synthetic synchronization is to support flexible synchronization relations between media. Fourth paper review is clock synchronization for wireless sensor networks. Clock synchronization is the process of ensuring that physically distributed processors have a common notion of time. The quartz crystals in each of the machines in a distributed system will run at slightly different frequencies, causing the clock values to gradually diverge from each other. This divergence is called clock skew. Clock synchronization is performed to correct this clock skew in distributed systems. Reference broadcast synchronization, RBS, is a clock synchronization protocol. It does not assume that there is a single node with an accurate time. It aims at merely internally synchronizing the clock. Last but not least, content synchronization using device-to-device communication in smart cities. This article uses direct synchronization and relay-assisted synchronization. D2D communication is a solution to offload cellular traffic, direct communication between two mobile devices capable of short-range communication without traversing the core network like the cellular. Content synchronization is the process to distribute the new content to all interested devices. Here is the diagram that shows how it happens. Here are the example of the algorithm used in this article. Thank you for spending your time. See you again.
Created using Powtoon.